sharing video ada dekat
Let me share with you the sharing materials. I put I just keep the link here in the chat.
sorry.
Can I keep the link in the chat for the download PDF?
Yes. You check.
Okay.
Dekat tepi. Dekat ada gambar cloud.
Ada.
Okay. Boleh read? Okay. Alright. So shall we start? Okay. Alright. Shall we? Let me introduce you for what. Okay. Alright. Assalamualaikum and a very good afternoon to everyone. So today is our HITeL webinar series 1 2022. Okay, so we would like for today's talks is about the basic of data mining using a Python, which is being our speakers will be Dr. Pradeep. So let me introduce about his profiles. Okay, so Dr. Pradeep Isawasan is actually the senior lecturer of the Department of Computer Science in the Faculty of Computer and Mathematical, Faculty of Computer and Mathematical Science at University Jemara. Okay, so previously, he will be part of assistant professor for Department of Computer Science, in Utah. Okay, so have a lot of achievements. Okay, one of them is he's also a top lecturer for the data science of MDEC. Okay, in 2019. So without further ado, we have allow the Pradeep to give his talk. Thank you.
Okay, good afternoon, moderator. So thank you very much for introducing me. And good afternoon, everybody. So thank you for joining this talk session. First of all, I would like to say thank you for the organizers. The organizer is actually HITeL. So today's talk is about when Sam approached me to find a title. So I was like trying to think a title that can be suitable for wide range of audience, because I assume the audience can be from different domains. Some jazz, some non-jazz, biology, economy, because data mining can be common in any field. Just the application or the technology might be different. Okay, again, thank you very much for allowing me or giving me the opportunity to present or to share. Okay, even though this is like a talk section, I want to make it like an informal sharing section. Tapah kind of formal, it's our kind of cookie. Right? So we make it very informal. So you guys can just interrupt anytime and ask questions or discuss. Okay, I have mixed a bit theory so that and also a bit of practical, so you can type all these theory. And then you can follow me with the examples. So the materials I have shared in the chat. Okay, in the chat session when you write this, I think. So there you're gonna see I provide two links. In that link, one is the folder where you can get all the files that I used today. But you just need the slides and also the data set. Okay, the data set. Maybe if you need the notebook, if some of you can you share with me data? Please share. Okay. I shared two links. One is from the another one is from the Google Drive. Any of these folder that is convenient to you. Okay, so you're going to download the slides that I'm going to use and also the data set. Okay, so we're not going to install anything today because installing for lab practice can be challenging because we are not that sure that what is your prerequisite, what kind of environment you currently are. So we're going to use a cloud platform, so that we all can focus more on the instead of troubleshooting the environment. Okay, so I think I can start. Okay, so I think the moderator already introduced me. I think most of you already know because you all my colleagues as well. Okay, so let me just share the screen. Share.
Yes,
Share the right screen. We check here. Can you see the slides up? Right?
Yes, yes.
Okay. Yeah. Alright, so I hope and I assume you would have access to the slides from the link that I gave. Okay, either from the Google Drive or you can just download from the GitHub also. Okay. Alright, so you can have access to these slides. So PDF slide, last meeting work. So I hope there's no error there. Okay. Alright, so let's start with this. Right. So the talk for today or the sharing session for today is about data mining and then I add basic there because I'm going to introduce very fundamental because the assumption of the audience is preliminary for fundamental kind of audience. So we're going to go very fundamental. For those that this is the first time they're exposed to Python, I assume you can be comfortable with it. For those that already have some familiarity, then you can actually advise me as well, give me some ideas of make it better. Yeah, advance so share. Okay, so here I'm going to introduce basically what is data mining. Okay, so I assume that most of us already have familiarity with data mining. So this is like a famous keyword nowadays, everywhere going to see data mining. But the thing is, we have so much alternate terminology used, data science, data analytics. Sometimes it can be AI, so many terminologies out there. So we do not focus that much on the terminology because sometimes depends on the domain, then the problem here I need to solve. So basically or simply, you can just say data mining is a process where you're going to extract insight. So the insight is the keyword from the data. So the data is something that is raw. So we're trying to find insight. Insight is like the some sort of information, knowledge. So the simplest is the collection of process of extracting insight from data. Okay, if you want to go very like deep like specific terminology or definition, I get from the textbook, the famous textbook now. So it's a non-trivial extraction of implicit, previously unknown, and potentially useful information from data. And exploration, analysis by automatic or semi-automatic means mostly it's going to be semi-automatic, but something even manual of large quantities of data in order to discover meaningful data. So the idea of meaningful, it depends on the domain and who are you actually. Okay, for some it can be meaningful, for some it cannot be. So again, it goes back to the domain that you are currently working with. Okay, I roughly introduce you what is data. So because we are working with data mining, so the fundamental of data is data. But again, because I'm going to focus only on this simple data, record data, some of you might be doing image related kind of mining or text mining. So the data change, but the process is still the same. But the structure of the data will change, and the tools and the technology will change accordingly. But for today, or today's session, so we're going to just focus on the most basic data or the record data. So if you see the screen on your right side, this is the table that you always see, everywhere you're going to see that. Alright, so this is a depth collection of two-dimensional array. It's just an array. It's a screen array. And then, but now when we store the array, we have some labels there. So I just go through some basic names or definition. Yang kata, so the column is actually attributes. Okay, but sometimes the name also is different from different field. Kadang-kadang kita panggil attributes, can be feature, can be column, can be variables. Not so many names are interchangeably used. And then the one that is going as a row, okay, that is actually object. Okay, so that object is also considered sample, instance, point, so many names and that. So depends on you. So you might have exposed to a different terminology, but it's okay. This means the same. So it's just a collection of attributes that describe the object. That's it. Right? But you'll be surprised. It's as simple as it, but it can do a lot of things. Very useful pattern, insights can be extracted. Okay, so the process is again the process also if you go to the literature or you try to do a search or go to textbook, it's going to be a lot also. So there's just to fix data mining to a specific process or methodology or specific definition is kind of challenging, especially nowadays where we're gonna have so many names. Nowadays I think you all are gonna hear data science more. But I try to stick to data mining because it's much more original. I can see it comes from historically, right? So for doing talk, so to make things very simple, I just separate the process. Okay, of course, if you look at it, it's going to be so many data understanding, pre-processing, data modeling, deployment, evaluation, but we make it very simple. We pre-process the data and look at all the steps, strategies that we can use. And then we apply modeling. So modeling here, we're going to use machine learning. Okay, so modeling here, we're going to use the machine learning. So that is going to be much more interest and easier to do so because the availability of all the tools are there. Yeah, very simple. So, but I will do this is not official definition of today for the sake of simplicity, so that we all can have a good time learning this. Okay, and then the technology and tools. Okay, this is very subjective. It's like I use Samsung phone, I use iPhone phone. We cannot compete with that. Everybody have their own advantages, and it goes back to the domain. Right, so let's say programming language. the currently that people widely use can be Python and R. Even Python and R also you're going to see because the R is better, Python languages. There's something always going on now. But we just look at the bigger picture. Okay, we everything has its own advantages, have its own usages, and it also goes back to the domain. Okay, where you're going to use it. So, for example, Python and R is very widely used in data science community. Okay, and it goes to software. I'm not talking about IDE. IDE means like Visual Studio Code or Spider. It's the software that goes on. The oldest one or the one that has been there for so long is Vector. Okay, so Vector is easier and it really can help you to go straight to the point. It goes straight to the point. But it has its limitation. But for the learning purposes, especially if you want to teach students or beginners, then Vector can be easier because you just open the thing and then just drag and drop few parameters and then you can see the result. Okay, but in terms of flexibility or the level of changes you can do is different. And then of course again recommend Excel pun boleh buat. Excel pun is actually very powerful to do a lot of data mining activities. Okay, then that can be done. Excel also very powerful. And then of course now we're going to see cloud. Cloud is another huge area, but it's everywhere. So of course you're going to see like us to really have the own cloud version where you don't need to install. I like cloud because cloud allows us to not worry about the environment, the configurations. Because sometimes it's going to be really troublesome for beginners to prepare. For example, let's say you're the first time, then I say, hey, you install Python, you install this, you install that. Then you're like troubleshooting it, then even that will consume you a lot of time, energy, resources. And you might end up giving up learning data science for the time being. So cloud is easier because you can just like go to the web and directly use and focus straightforward to the problem instead of worrying the configuration. Power BI, Tableau, and today we're going to use Google for that. Okay, show you. We all going to use together. I'm going to use Google for that. Okay, that is the tool. So all these are cloud based. Okay. So since we started about Python, then of course I need to introduce you to Python. So it's a programming language. Here is high level programming language. Why I say high level? If you're from CS background, you know the low level language and high level language, right? So high level language is much more human readable. Okay, the syntax is much more readable. Like look at the syntax, you know what is happening compared to low level languages that is much more much more machine language. For example, I think some of you might be exposed to assembly language and learn English will be like. Okay, so for those from engineering background or computer architecture background, so that is like kind of low level languages. Means that it's very close to the machine language or binary language. Python are all considered high level language, where it's very close to the spoken language, like kita cakap, very close to English language, right? So, as I mentioned before, it emphasizes on code readability. Why? Okay, why? Because you want to focus more on the problem. Okay, so the learning curve is supposed to be shorter. So we have a problem we want to solve, then we can focus or spend time or resources there instead of all the hardware and all the technical kind of requirements. So once your code is readable, so the learning curve can be shorter. So you can adapt or learn this language much faster. This directly increases the production or productivity. Okay, for example, you're starting a project, you need to finish in 3 months. Just imagine you need to spend like 2 months just to learn the language. Okay? So this is the focus. Even R also the same. So it depends. Okay, if you want to go advanced, you want to add on focus on programming language, then you can use the cloud-based like Power BI and all these things. Alright? And Python is rank number 1. Okay, in terms of programming languages currently. They rank according to HITeL spectrum is a valid body that we can trust. This sort can be trusted in Okay, so they are actually a valid, and the methodology for them to measure this rank is quite valid also. So, we can trust the ranking. So, again, number one. I think for the past 2, 3 years now, maybe for the past 2 years. Okay. So, rank really doesn't matter. I just want to show you that rank shows the usage, means more people are using the popularity. It just shows that it doesn't show anything. It doesn't show it's better, but it just shows the popularity. Okay. Alright, the final line is the risk. Okay, even R also the same. So means I can even say the pushing factor for all these languages is their libraries. Without the libraries, it's kind of you're not going to do anything actually. So the libraries is the main ingredient that pushing all these languages. Okay, so there's so many fantastic libraries in both languages, Python and also R, that can help you or makes your productivity better. Okay. Alright, so I want to start the pre-processing. Okay, so after this, because kalau saya cakap bila dia buat this weekend, so let's do the activity together. And it's not going to be very difficult. Let's say this is the first time getting exposed to this. Don't know what it's supposed to be competing actually. So what we can do is we just open Google Colab. Share with you. Okay, so this is Google Colab. Okay, I share in your chat. Where is the chat? Yeah, so I need to exit the screen, then only I can see my chat there. Oh, okay. Okay. I know how to. I expert web reading, right? So if you see, I share a link. Okay, that particular link is for you to open your Google Colab. And so you can use Google Colab. So we're going to use this afterward, continuing this session. And you don't need to do installation or anything. Just can open this using Gmail account. Any of your Gmail account you can set up in. So just use this link and open. Then we do this together. Alright, so you're going to have a page like this. Okay, you'll have a page like this. So that's it, the code part. And then if you want to use a text, okay, so you can just type text. So means there's only two. One is the programming language where it's going to execute the syntax. Second one is not a because markdown language is like a markup language, like HTML, markdown, all are considered a non-programming language. Right? So kita akan guna markdown methods ini. So let's say, my. So markdown have few syntaxes that you can just remember, but Google Colab, you don't need to remember these syntaxes. You can just use the interfaces here. So like you have bold, or you guys want to make it as a header. Okay, so for example, let's say
Pradeep, they have one question from Yasmin Fazana. Okay, they ask you, Doctor, I would like to know then can Python can be used for panel data?
Yes, can, but if I want to know what is the detail about the panel data, one actually can. Right, so my first Python. So if you want to change the header size, just like this one, HTML, it's very straightforward. And then you can rearrange where you want to move your. Rearrange where you want to move your. We call this as a cell. Okay, so basically these are the two, the only tool you're going to need to do this activity. Right, so you just can just anything. So this is where you execute your code, and this is just where you write, whatever you want to write the processes. Okay, so please let me know if you are, you have trouble. This you don't need to install anything. Just open this. Right, so we can continue our lab in a. Alright, so let me just show you one by one. So it's the same because I use a different thing because easier for me to show certain students, and you all can use Google Colab because I want to show you different tools. Okay? For example, the one Google Colab is a cloud-based, you don't need to install it. So what I'm using is VS Code. It's involved a lot of pre-configuration before you're able to use it. Okay. So let's do the first part. So the pre-processing part. Okay. So the most important thing, as I mentioned before, is the library. Okay, so the library is going to be the most important thing. So whenever you have a problem to solve, you need to identify which library is going to be suitable. Okay, this kind of thing is applicable in both Python and also R. So these are the library is the one that can help you to use it in things or enables you to use it in functions. For example, here the most famous one, or I can even say the backbone of most of the data mining projects is Pandas. Okay, so you can Google that. It has a longer name. It's actually an acronym for longer name. Also, data analysis or something like that. Okay, Python. Okay, some full name for that. You can just Google for that. But mostly we're going to use Python. Sorry, Pandas for data analysis, manipulation, and any sort of data mining. Okay, and even you can use some for visualization. But because today I don't want to confuse you with a lot of things, I just want to stick to two libraries. One is Pandas, even visualization, I'm going to use Pandas. Then I'm going to use another library for machine learning. So let's start to do the code. We just start and I am marked down to do. So maybe I can see here. Okay, let's say import library. Right, so we're going to import our library. So the code here. So let's say import Pandas as. Right, so in Python, import is used because why I like programming languages like Python, because you just call what you need. You don't need to install everything. And for example, other kind of tools. You have to start writing there on the useful. For example, these I know today I'm going to use pandas, just import the pandas. It's already done. Even in Google Colab, you do the same thing. It works. Okay, if you open Google Colab, so you can just use the same syntax, the same. Then you just run. Okay, so this is the first thing we do. Usually we import library first that we want. Okay, now we're going to read the data. Okay, you can actually follow the slides also. The same material is available in the slides also. So we can actually read the data. So after we import data, let's say I had another data. Let's say this is data. Okay, and then you just read the data. Then you could. Okay. So I name my data as PDF. You can name anything you want also as PDF if you sign a names also. And the syntax that I'm going to use is EB because can you see this? So it knows now my pandas is called as PD. So technically you have to use pandas PD. So we just use PD. This library is considered PD is part of the module. Then we use this dot. Okay, so dot is the one that tells you from this library what is the function that I'm going to call now. Okay, so one important matter is I'm not sure that we can't remember all the functions on that. Okay, everybody gonna Google, everybody gonna do a Stack Overflow. Okay, so we can't remember every single syntaxes, but the most common one we will know. And thanks to all these IDEs, we don't need to remember all this. For example, I use VS Code. Can you see I just read? Gives me a list of functions that I need. So I'm just gonna use this. So if you guys are using Google Colab, it's gonna be the same also. Okay, so if we check with Google Colab, you have the chance to work with different data, then it's going to be different. We're just going to read all these things. Okay, so you guys can explore this on Google and learn more about this. I can put this so that you know what is SEPA, what is better. Okay, so this is how it's actually described. So now let's read the data. Okay, so what you need to do is depends on your location. For example, mine is here. Okay, so I just copy parts. So you can just follow my code in the slides as well. Put it constructive like this. And put the part. Okay, so yours for Google Colab. Okay, so for yours, what you need to do is you open your folder like this. Okay, can you see like a file here? you need to get the file that I shared in the folder just now. That's the Google Drive and also the GitHub anything. So you just get the data set called iris 30. Okay, you just get the data set called iris 30, then drag and drop here. Right? So it's going to be this very small data set, so it's not going to take a lot of time. See, already is there. So what are you going to do? So import, then does, okay, and then we have ed is the data that we want. So we CSV, just follow the code. Okay. We go here. Then can you see there's a copy part here? Copy part here, you just copy the part, and then just paste it. Okay, I think for those that are already familiar with this, I think this is kind of easy for you. If this is the first time for you, don't worry, this is how you're going to do that. So the data set is already from the drive, you just download and drag and drop it. Okay, and another important thing is Google Column won't store your data. After some time you never use, this data will be deleted. So whenever you run the code again, make sure you drag and drop the data here, and then you just run. Okay, and then you're going to run. Okay, that's good. So if you have any problem, you just let me know. So now we run. So your data is already imported. So what Panda stores is it takes your CSV file and stores it as data frame. Okay, so the format of the data is called as data frame in Pandas. And this is how your data going to look like as a data frame. Similar temperature data set we have in the filter. Okay, so we have the supply length, width, that's the length, that's the width, species. So you have the information that you can get from here. So that one will do it later. So in data frame processing, after you import your data, the next step is you got to do some basic analysis. Okay, so what we're going to do, we can actually use the I'm not going to go every single code. You can just follow the code by yourself as well. If you're curious about what we can do next. And then the code after this I'll share in the same link. Then you can just download it and try yourself as well. Okay? And then HIT, you can have some information about it. You can even try HITeL. Okay? It's like a peek inside of the data set. You think what is happening, how the data looks like now. It's still fun. Alright, so make sure I need EF, so everything you use is EF. Okay, so what else I can do? I can find the shape. Alright, so I can find the shape. Which shapes gives me the dimension of the data. So by looking at the shape, you get a tuple saying that this is 150 row and 5 column. Okay, but the thing is, I want you to think. So can you see by doing this, you need to think. Is it there is something wrong with it? Because if you look at this information that I do, okay, you can check this. So row is actually complement, okay, column okay. So you need to keep on checking whether everything is matching. So this is what data frame processing is about. You understand the data and making sure everything is fine. Okay, so I can use, and then I try to use it. I use here. Okay, now let's use in shape. Okay, fine. Now let me use info. Another useful function. So info gives me how the data is going to look like. Okay, okay, so info. So it gives me the properties. I think there's an error in the slides, but the info is supposed to be subtracted. So you just need to put a bracket at it. Then you know, you get the information of the data set. You know what is the column name, what is the type of the column, because I didn't discuss very detail about the type of the data set, but basically you're going to have number and also category, numeric and also category. So that's the two things. Okay, so you just imagine that this information is important because now you know already. By having this information, what kind of problem I'm planning to solve. Okay, so that's why now the statistical knowledge is important. Your background or some prerequisite or prior knowledge on statistics is going to play its role. So whenever you see this kind of data set, numerical or categorical, then you need to think what I'm going to do next. What kind of problem that I'm going to solve. Okay, so now jump into the statistical description. So once you know the info just gives you the idea of how this picture, the picture of the data set. Okay, basically, that's it. And you're going to have another information. This is quite important in the for you. So it shows you, it's supposed to be a good data. Why can I put it as a So these are the things you already need to identify something wrong with my data set. I need to do something else. So now let's go for statistical description. You can try describe. So describing tables juga lah. Mostly we will use this. So describe gives you the statistical properties of the data set. This is very important. Okay, pre-processing stage, we already do the statistics, but meanwhile we're getting the descriptive statistics. Okay, so you get the count, you get the means and the deviation. This gives you a lot of information about the data set, how they actually distributed, is there any outlier? So these kind of things you can find out. But again, this goes back to statistical knowledge or statistical background. And one thing I want you to note is that this gives me only the numerical values, that is the number of whole. But you guys notice that the species need a number categorical. It doesn't give you any statistics for that. Okay, by default, it only gives you a numerical values. Because categorical, we cannot find mean. Again, it goes back to statistics. You need to know the data that you cannot find. So when it's categorical, what we do? Use you use the same word, but you mentioned that you want to include the categorical value. Okay. So if you want to include the categorical value, then then you get species 150 rows. Because categorical values that are built of discrete. So discrete, what we usually do is we find frequency or we find unique values. That's the only thing we can do now. We can't do the average volume. And what is the top? But something wrong here really. Okay. You need a 4. But if you look at the data set, we suppose there only tiga, that is the dosa, versicolor and vertical. The tiga jenis dua saja data set I think. But yours is giving 4. So you know something wrong. So can you see now? This is what data mining process is all about. Every single step you need to check, is everything okay or not? Everything okay or not? It's about the process. The whole data mining. When I see this, it is supposed to be figures, but the figure bukan saja because itu sentosa, versicolor dan vertical. Kenapa? Why there's a 4? So these are the questions that you need to ask, and we're going to investigate further. We're going to keep on investigating. Okay. Let me answer one question from Muhammad Nasir. Are there any? Yes, you can just specify the part because since we are using the cloud, so you just use the part. If you're running this on your own machine, then you specify the part from the machine. Just by the But in the cloud you can't do that because mine actually can do because I own machine. Okay. So let us continue there. So this is described info the statistical description. Okay. So now you know there's something wrong. So now let's do data cleaning. Okay, so cleaning is the widely used name. Okay, even in R, you're going to see we call this as a tidy data, tidy kemaskan kan. So sometimes we call this cleaning. In R is a very specific name. We call this as tidy lah. And even you can call. So that's why you see the data that I give you. Finally, the ID is 30. So it's opposite. I mean, I think the real data I simply roll certainly and then I share with you guys so that we have some cleaning to do. Okay, so what data cleaning we're going to do is try to summary. Okay, that's good. So first we find the missing value. Okay, so because it's very basic, each of these, if you want to go deep, it's going to go very deep. So missing value itself, it can be a whole chapter. But we're going to go very basic. We just look at the fundamental. So missing value is not as any that you're going to see as that means not a number. Okay, so usually if you open in Python, you're going to see it as NaN. So if you open your data set, okay, Excel or any types of okay, let's be open the data set in Excel or Linux, you're going to see it presented like this. Okay, so if you can open in other platform and try to serve and check what is happening here. So all of these represented as such. Okay, so these are considered as missing value. Means that the value is unknown. It's very, very important in accounting because in real world, it's going to be a lot of this.
Pradeep, kalau table tu selain daripada kalau dia empty, is it considered as boleh clean tak?
But usually empty will be replaced by empty actually.
Oh, so kalau
unless
empty lah.
Yes. Usually empty will be replaced as unless ada values macam koma, macam kosong atau simbol-simbol lain. Later I'll show you how to do that.
Okay, thank you.
So now, if you have NA, it's going to be very simple. NA is the most easiest way, which is already developed for you. So we have use as this, okay, and then I try to count how many I have. Okay, for beginning, I start with the syntaxes, I will be like, what is happening here? But I just want you to look first. And you see, I use a lot of dots like this, and I'm using a lot of functions like this. So I'm calling other functions this way. Okay, so I'm going to use EF. Let me just check that. Wait, okay, all right. So this gives me the missing value. It's already helping to count because what it's actually doing here. Okay, I have the time right. Okay, what it's actually doing here gives me it checks which one have value or not. So what I'm counting is those that is actually false, and then I got how many that is missing. So vector length dengan vector width ada masalah at all. Sepal length dengan sepal width ada 8 and 11 missing value in that particular column. So if you look back at the info, you already know the info just now. You already know this particular information. So sometimes you just type info, you already know if it's a missing value or not. Means you're just checking whether a value is null or not. Okay, macam tadi Sam asks is empty lah. Okay. So there are a few ways we're going to handle this. If you look at the slides, after we identify or find the missing value, we need to handle it. We handle a few ways to do that. The paling basic way, we just remove it. That's the most easiest way you can implement it. But the thing is, information is very valuable. It is very important for us to keep as much as possible without any manipulation or changes. So it's not recommended for you to just remove it unless the worst case scenario you can really justify. We try our best to keep the data set. Of course, practically the uses to secure it. But usually our practice is we try our best to keep it. So we don't do that. If you want to do, you can just follow my code there. Just remove one. So it's going to remove 8 dekat sini, 11 dekat sini. It's going to reduce the data set. That means it will become 150 minus 11. Okay. Another one is we're going to fill all these values with 0. Okay. Another one we can do is we can just fill this. Fill all the new values with 0. Okay. be filled with 0. But again, statistical wise, this is not recommended also, because if you fill with 0, the distribution of the data, is going to make a mess. Okay, we really don't know the range of your data that you actually store. Then you simply fill 0, then it's going to really disturb the distribution of the data. This is not recommended also. Okay, so can you see, there's so many strategies we need to think, and of course, this is statistically supported. So one of the best way in missing value we do is we replace with the mean value, so that we can still maintain our distribution in that particular column. Okay, we can just maintain, maintain the distribution. So in order to do that, for example, just now described here, right? Just now we try to find info. Okay, let me just add one more here so that. Yeah, so we go data info just now, okay? Here the info, right? So this gives me a lot of information. And then also this one gives me the statistical distribution like mean, standard deviation, and all these things. But if you want to find specifically one, you can even do like this. The mean, and this will give you the mean for each of these. Okay, for each of these columns. So this is what I'm going to do. What I'm going to do, I'm going to replace the missing value with this. So that this is one of the ways. There's so many ways. People even use linear regression to predict what can be the missing value. That is going to be very advanced. But for now, we're just going to replace with the mean values like this. Whatever value missing in that particular column. But this practice column, we cannot just take from this column and take the column later. So I'm just going to replace this with my DT. So I'm just going to care about the numeric one thing. Because here, because you can't find the mean for the categorical value, so it's trying to count that, and they say it's correct. Okay, so we just try to find this, and it's gonna fill my values here. And let me update this into a new data frame. So if I need a data frame start to, okay, you guys can name it into one. I call this a data frame 1 because I'm creating a new data frame where the whole data frame will be replaced with the mean value inside. Okay, so it's going to be a 1. So now if you open it, see, all the missing value will be replaced with the mean value. So, you're just making your data better before you can apply some machine learning. Okay. Alright, so another thing is now you already handled with your missing value. Maybe we can now focus on problematic value. So means missing value is usually not a problem because we know already there's any end and we just replace it any strategy. The problem usually happens with unusual value, or sometimes we refer them as problematic values. Okay, for example, typo. Because data is collected by humans, for example, there are chances to have a typo. Let's say your RA is collecting data, then type of the lead comment. So we have to do some decision there. Okay, is it like really bad to guess, or you just assume a small typo? I created a simple typo here for you to see how it's going to look like. And if you double click and open your file, for example, you can see that it is open into Excel, but I just want to show you with Python so that in Excel you can do it for one point like this, not a problem. But what if this kind of thing is repeated for 1,000 times? Then you need some sort of automating tools, right? That's why Python will be useful. That Python or R will be useful in that particular kind of stage. In small stage, I think we say, oh, you just can go here and just type and change back to or applicant. So we need to find a way to at least semi-automating this process. We can't do like, let's say you have 1,000 like this, we can't like change all 1,000. Okay? So let's continue with this. So I'm just going to quickly do this. This is the product and the week. Okay, I identify what is unique here. So you see, it has the dosa, it has versicolor, it has virginica, and I don't know what is this. So there's some problem in your data. So very high chances by using our logic, we know this is a typo error. Okay, this is a typo error. So we can just quickly correct this. Okay, we can quickly correct this. Just, or you can even find other things. Okay, actually start to count. And then you can see the problem here. So versicolor is 50, virginica is 50, but Sentosa is 49, and something one is 51. So, you know, logically we know, okay, we not typo lah. And we just need to correct this. Okay, the decision is made by you or your team lah. Still, human interaction is needed to make the decision. Okay, and you can just follow my other course for extra things. So I'll try to finish still at the time. Okay, let's continue with this now. Once you identify the problem, you just need to replace this. Okay, so now I update into a new data set, the frame. So just use P1 and I replace. Can I say code readability here? This is what I mean by code readability. Just like I say Python is readable. Can you see now? Replace means replace. Not like C here, you have to like write the function and things like that. Here, replace means, you know, the process you understand is going to replace something. You just need to make sure the parameters. So that's why I say Python emphasizing on readability of the code. So let's do a big analysis. You can, see what is happening here instead of like totally like not sure what is happening there. So then we go here, Sentosa. So I'm going to replace with this problematic instance of point here into this that I assume I'm going to group this together. Okay, done. So let's see your cleaning. So I'll make it today activity is very simple so that you just do two things. But real world data is not going to be as simple as this, but today is mine. So now my clean data will be DF2. DF is considered the data. I did two steps and now I have a clean data that is DF2. Okay, now we go to visualization. Okay, there's a link there. You can just open the link. I have post. If you want to go advanced or you want to know further about all this processing, just read from the link that I provide. Okay, so it will give you the detail or the exact or further details if you're interested to know more or more details about all this. So now I'm going to the next step after data cleaning. See in the pre-processing, kita pergi kepada data visualization. So after we clean the data, we need to visualize. Okay, visualize is a very tricky part. So why we need to visualize? There's always a question about that. And when? Sebelum atau selepas. Okay, so visualization is something useful. If you see here, visualizing data prior to analysis is a good practice. I didn't do this here because I just want to follow the process so that you can see. But you are able to visualize this earlier. You can easily detect the missing value already. Something wrong there. If you visualize this earlier. So that's why it's recommended for you to visualize before even you do the cleaning so that you can identify the problem. And some of you might say, okay, detail about statistical description is already there. Okay, why we need to have visualization? No. Statistical description is not sufficient to capture the data set activity. Means it don't give you the whole picture. Yes, it does give you the mean, it does give you the average, all this thing, but it doesn't give you exactly. Okay, why? Okay, you can but then post the video. Okay. You can check this video when you have your time. In here, I explain why statistical description can deceive your mind. Okay? When you see the statistical description, you're supposed to have everything looks fine. But when you visualize the outlier, the non-linearity, so many things exist. So it's a very famous case we call as Escombe content. So you can check out the video and I explain the whole thing there, why statistical description is not sufficient for data cleaning process. You still need to visualize. So this cheat sheet here, okay, it is good enough. But I try to get a better image, but this is the best I can give. But when I make it big, I notice this. But the idea is there. So you can decide what you want to show. But today, most of the data mining kind of process, we like to show the relationship. Distribution is mostly on the pre-processing stage, so you want to check the data is okay or not. But in relationship, we like to use scatter plot. Okay, so let's quickly go there. Okay, like to put touch code time. Yeah, let me just read the chat for a moment. Yeah, you just you open the Google Colab. Okay, so you just drag and drop your data here. Okay, so wherever your folder is, you just drag, you just drop this area here. And then you can just follow whatever the code in the slides are. Okay, but you can see like what Mr. Kamaro mentioned, you can see mount to your Google Drive as well, if you want to be it to be permanent there. Okay. Thank you. Alright, so let's continue this, the visualization part. So let me quickly do the code. Right, so I'm going to do a very simple plot, a scatter plot, and to make things simple today, I'm just using the pandas library because we have very fancy chunky kind of library. Okay, Seaborn, or can do very interesting visualization, but it's going to be a different session itself. You want to go through that. So to make things simple, I just use whatever exists in pandas library. So we just scatter plot x and y. So any two independent variables we can use. So instead, I'm just going to use spectral length like that. Y. So you can try few ways. You can do not put x, y composing. This is going to use spectral. Right. So you gotta get scatter plot. Okay. Alright, so the code part, I hope you can just follow my slides and run the code by yourself. I'm not going to go every line of code. It's there for you to try. But now the question is, I want you to think, once you do visualization, you can see the most important thing in data mining process is whenever you see this kind of visualization, your ability to see the pattern. The first level already you can see something is in the channel pattern. So this is, you can easily see positively correlated. That means the better it goes up, the better lag will also goes up. Very easy human observation that we can do. You don't need to do very technical ideas, and not yet, but if you look at it, you already know, better it goes up, better lag also goes up. So there's a, I would say, correlation positive. Okay, and I'm not going to talk about linear kind of separation yet, but we can see a pattern that is the first thing. But now you can consider, okay, so now you can consider, maybe I can use the click copy paste method. Okay, so now what I did here is I add color. Because usually I will always say, color in the data mining is not only for kecantikan, not only to beautify the thing, it's supposed to carry information. Okay, so we call this the third variable. Okay, so let's try to use the same plot, but now I add color. So the color, because color is a distinct value. Okay, so color only can represent discrete values, categorical values. Dalam contoh ini kita ada 3 rumah, unique value sentosa berjadikan asal-asal color. So we can plot this according to color. Compared to the previous pattern. Now you have a better pattern now. At least now you know things are going down, like correlation policy. Now, once you add a color, the third variable, okay, the discrete variable, now you can see something totally different, and the way you interpret this also is going to change. So that's why visualization is going to be very, very important before you go to modeling. Okay, so if you look at this, what do you see? But that's the first question. Whenever you see visualization, you need to ask yourself, what do you actually see? A lot of things you can see, but again, it goes back to the statistical knowledge of yours lah. Tak boleh lari daripada statistics lah. And okay, so now I'm going to go to the next part. So basically, the pre-processing is done. I think it's the pre-processing. Okay, so after the pre-processing, we're going to do the machine learning part, the modeling part. So of course, I'm going to use machine learning as my model, then I just say machine learning part. So there are a few ways in machine learning. So because I don't want to spend a lot, we just assume that it's machine learning. For now, we have two problems we're going to solve. Okay, classification and the clustering. For example, simple leaf and distribution. So classification is supervised where you have label, and clustering is unsupervised where you don't have label. So let's perform classification because our data we have label. Label there we can see it as a dosa, virginica, and vesica. That's a label. So it's considered as a supervised learning. So when you look at the pattern measurement, what do you see? It's pretty obvious. We as a human, the virginica has larger vectors. Okay, yang biru ni. Kita tahu dah, first insect. So it's a very important discovery you already made that virginica is actually bigger compared to versicolor, and merah ni adalah sentosa, they're always very small. Okay, that's the maximum it actually can grow. So it's very important insight that you're able to find. But the thing is, we as a human knows, but machine does not know about this. So we want to make the machine knows about this. So this is where machine learning actually comes and plays its role. As simple as that. Okay, we want to teach machine what we actually are seeing by using algorithms. Okay, so we go machine learning. Sorry. Alright, so machine learning. So now we're going to do the first part. So again, so just now kita buat pre-processing, library yang kita pakai adalah pandas, insufficient. Can you see I can do so many things with just pandas. I didn't call a lot of libraries and all. Now machine learning, I'm going to use another only one library called. Again, there's a lot of names. How support like HITeL, HITeL. You know, there's so many ways people pronounce this. Okay. So I'm going to use HITeL. So I'm going to call something from a linear model. Because if you see this is a linear kind of problem, we can easily solve this. If you see this solving the vector length. Okay, so I try to get something from the linear model. And I'm going to import logistic regression. Okay, logistic regression is a very famous or fundamental regression algorithm works on categorical value. Linear regression doesn't work on categorical value. You know, we all used to do linear regression, but we just focus on regression on numerical values. But when we have categorical value, then we can use logistic regression. That is what I'm going to use today as my machine learning algorithm. Okay, so the machine learning is done. So let me just, okay, so now did you notice that just the pandas are import pandas as PD because I need all. But now the library logistic regression, I don't need neural network, I don't need k nearest neighbor. So I didn't call them. So that is the good thing about programming language itself. I don't need to install or call everything that just use. So this makes the productivity faster and it's much more efficient. Just need logistic integration and just call that. So whenever you have a problem, you can just Google your library help, and then you can know all the links. So what I'm going to do is, okay, so before that I need to split this. So machine learning is something where usually what we do, we need to teach it. But when we ask the machine, when we want the machine to learn, we want the machine to test also whether dia learn bagus atau tidak. So for that, we're going to use a sampling method, atau kita panggil a resampling method. Okay, so this is for hold up method. Okay, so I'm going to use the hold up method. So this is one of the basic way of resampling or sampling method. Okay, I'm going to split the data set into two. That is actually training and also testing. Training is the one I'm going to train the machine. Test, I'm going to test the machine with whatever training I did previously. So you can just follow my code there as well as it. Okay, so I'm just choosing my variables. Alright, so I have the time. So what I'm doing is, you maintain the classification model, we need to have predictor and also the target. So X is going to be all the input, that is the 4 attributes that you have. Separ length, separ width, petal length, and also petal width. Okay, and then based on that, I'm going to predict my target that is actually 1. Here, my Y is going to be the species. Okay, and then I'm going to split the data set into 80-20%. Okay, I'm going to split 80%. Alright, then I'm going to split 20%. Okay, so this process is randomly happening. So means that you and me are going to have a different split. Even if you follow my same code, the process is for now because I didn't set any seed. The process is going to be random because that's how statistics works, the sampling. So what I'm going to do, I'm going to split the data set that I have that is actually okay. So into 80% to 20%. 80% I'm going to use for my machine to learn, and after it learns, I'm going to test that you learn bagus atau tidak with the testing data set that I have. Because you can't train it 100%, then you can't just wait for the unknown data to come in, then only you can't do that. So you need to split. This is one of the easiest way. And another way is cross validation, but I'm not going to discuss it. So every single step there is other ways. I hope you notice that. If I do this resampling technique, then you're going to see this another resampling technique. And we don't know. It can be better or it can be worse. Alright, so okay, so let's try this. So let's see what each of these, what I am able to get. Okay, so let's look at what is my X now. X is just this, the 4 attributes that I'm going to use to predict my target. There is the per length, the per width, the per length, and also petal width. I hope you notice another thing. I didn't do any other pre-processing. I didn't do normalization. I didn't do scaling. I'm not going to do any feature selection or so. This is all the questions that you need to ask when you do any types of data mining process. And it's going to do something. This is my Y. Okay. This is going to be my target. That is the species of the flowers. Imagine I didn't do data pre-processing just now, I didn't clean. So imagine this part is going to be like what? There's 4 variables and then. So you're going to feed the algorithm with the bad data and it's going to give you, suddenly the result can be good also, you know, sometimes you'll be surprised, but the process is already wrong. You feed it with the bad data. Okay, so the ultimate goal is not finding the best accuracy. The ultimate goal is to find the process is all betul, then also then we get the best accuracy. Okay, let's try to find my x. Being data. Okay, see, remember earlier we pakai shape to find the size, right? We can just use shape. We know getting data is 120 by 4, row is 120. So if you look at your color x 320, then x test is going to be 30 lah. 30. So now the question that you might ask is why 80-20? Okay, that one I can't give you the exact answer, it depends. Okay, it can be 80-20, it can even go 90-10, it can go 75-25. You know, if some of you have an explanation for that, you can explain in the chat session also. What do you think the best value here? Or the best value going to be when you do the training, then only you give the values which one is going to give you the optimum, right? So you can discuss in the chat what do you think the best value. Okay, for now, for today's example, I just use 80-20. But the rule of thumb is that I can say is we just make sure that the training data is more than the testing data. That we know the training must be more than testing, but 80-20 or 70-30 or 90-10, 95-5 is subjective to the experiment. But it cannot be 100. We must split this. So these are the splitting actually done. So can you see why I say 80-20 is this is the proportion? Yeah? This is the proportion. So the test size is 0.2 is 20%. Okay, so you can play around. If you want it to be 30%, just change this into 50%. Okay, I mentioned to you that this sampling is done randomly, and you and me might have a different accuracy and even a different prediction. So if you want to make it fixed so that you and me have the same random state, then you can just fix our random state into some value. Let's say 1, 2, 3. This is like in R, I think it's set C. Okay, so you can just use this random state. So if you follow this code, you also see random say 1, 2, 3. Both of us going to have the same split, randomly split. In the random process, the state is the same. Okay. For now, I'm going to ignore that, just for extra knowledge to know. So that is fine. So we already split using formula method. So now let's go to the algorithm part. So means that after you've done your building on, then you come to the library, you get the machine learning library, and then you use the formula method. Then we go to the algorithm. This part. So let's go to the algorithm part. So algorithm itself is huge. Okay, it's really huge. It's kind of challenging for you to know all of them because today I'm just assuming I'm going to use only. The chances for you to not that sure about how the algorithm works is still there, but you can still use. But it's just that you can't know which algorithm will be suitable to which situation. So by knowing the fundamental of the algorithms or the statistical algorithm, it's better. So machine learning, machine learning originally you can even know the statistical learning. Okay, so most of the algorithm are statistical in nature. So that's equal. Alright, so I'm gonna use my algorithm. So let me just import media. Integration, logistic integration. And then I go to the slide. Logistic integration. So very important. So from so I hope you're getting comfortable with Python code Retina from SK. That so you can use tab as well. And I need linear model tab. Then when I import tab, when we use logistic tab. So the tab is going to be your friend with the code. So from SQL, linear model import logistic integration. Very simple. Kalau you gonna pakai algorithm ni, you just try to find which syntax, then you just import that. If you want to use KNN, then you try to find the required syntax for that. You can read the help. Okay. So now what I'm going to do, I'm going to create the model. Create my machine learning model. I just name it as model. So let me name it as model. Alright, so the function, see, remember what I call here? Logistic regression. So I'm going to call this logistic regression now. Right. So, okay, for now, do not change any parameters. If you see in my slide, I put there the max iteration for 150 because when I was experimenting this yesterday, because the data set is small, it's giving you a warning. It's not a wrong, but it's giving a warning for the convergence. So this adds an iteration. So it doesn't really matter, but having more iteration, then it won't converge. The error won't pop up. So this is sufficient. So the model is just linear regression, and jump is a train our model. So now the training is, it goes back to just now we as a human can observe a pattern. But how the machine want to know? By using an algorithm. So this is what we are doing now. So we're going to create the model. We're going to fit. So model is because of this. Model comes from here. Then I'm going to use the same model. And the function I'm going to use is fit. Fit. So fit where? So we're going to fit inside the only the training. So the test we're never going to use for it to learn. It's supposed to be like that, okay? We're going to use X. X here. Okay, okay. And then I'm going to have Y also. Okay. Alright, so I'm gonna train this with this model. So I'm going to use logistic regression and I'm going to train with those data that I split here. And this okay, not this one. It's going to be very fast. Sometimes I think you might heard the stories about running or training. Sometimes it can take weeks. It's true, but it goes back to your problem and then the data set. Okay. So especially those that dealing with video data or image data is going to be different. Our data is very, very small. So that's the of those rows answer. So it can run in 0.4 seconds. So it's not going to be a problem now. But I'm very sure you heard before that people train your data almost 3 or 2 weeks just to get some better insight. Okay. Alright, so this is that. Okay. So this you already let your machine to learn from the past data that you have. But the thing is, after you learn, then you still aware or you still need to evaluate the model. So it means whether your training is good enough. So let's say if you don't have this step, and you're gonna simply train everything with 100% data. It doesn't it doesn't make sense because you still need to test it how good your model is done. Okay, let's go for evaluation. And while we are doing this, I want you to notice another thing. By having a notebook as such, everything is recorded. So means the whole data mining process is recorded. You're having the code, and you're typing, and you're seeing the output. So it simplifies the process of doing data science project or even data mining project. So now I go to evaluation. Okay. So evaluation also is it's only in classification because they're doing classification, and this evaluation is specifically for classification kind of problem. So we have a lot actually, but today for simplicity, I just focus on two things: accuracy and also confusion metrics. But it's not enough. You have other parameters or metrics, sorry, like recall, F1, precision, and all this thing. But for us, we just assume accuracy is the ultimate number that gives you how good your model are, and we can use comparison metric to look at our accuracy also. Okay, let's continue doing this. So okay, before that, okay, this code I didn't put in the slide. Alright, so before when you come to evaluation, so you already trained and you actually start to test it. Okay, so how are we gonna do this? Just gonna use our, let's say I wanna find human and call this. Then I'm gonna use the model just now. I'm gonna predict because I already free that. Then I'm gonna predict with my X. Okay, because why test? We are not going to do anything. Yeah, I hope you can see the picture. We divide the data into two and just say extreme, y train, x test, and y test. Okay, after we train x train and y train, we try to fit it and ask it to learn the linearity or any types of pattern. And then what we're going to do is we're going to test with the test data set that we have that we never touched or never seen before, unseen. And then we're going to generate a new one based on whatever the logistic regression gives you. So the new y, we call it as y predictive, or after you the y new, you can use anything. I say y because here I use this again. I have to add this line to slides. Maybe I'll add this later. Okay, so now you have a new y that is generated based on the learning that is actually with the training data set. And then it uses this input, that is your test data set, and then it predicts this new one. So now we have a y that is predicted, and then we have a y that is actually real. So now we can actually compare that output model. If you're waiting for the unknown data that's going to come that is not inside the data set, then it doesn't make sense. So let's continue this. Alright, so we have okay, this. So let's play around with two matrices. So for that we need to get we import the matrices. Okay, so let me import the matrix. So the first matrix that I'm going to use is find. Let's see. Okay, I'm going to find accuracy. So how to find accuracy? Okay, accuracy is actually simple. Let me just share with you what this accuracy is about. Okay, accuracy is just if you take the correct prediction, okay, the probability lah, correct prediction divided by odd prediction. Okay, again, there's a video that you can watch. I did explain in details how each of these values are actually calculated. Okay, so there's a very important concept here. We call this is false negative, true positive, this kind of statement. So I explained in that video. You can go through it and try to understand how it's actually exactly calculated. But accuracy basically this. So what is going to do? If you find it, before just using the syntax, let's see what is happening here. Okay, let me just do something. Okay. This is easier for you to see what is happening. Okay, I just create a row of two of these. The one that we have currently predicted and the one that you already have. Okay, so let me create a table, a data frame, so that we can compare side by side. This is what your model predicted, the output. It does, this is able to do. And let's compare side by side. So this is what it's having. You're going to have 30. Because just now, still remember that we split 120 to 30. So it's going to be 30. Let's just look into this. Just roughly look at this. So the left and the right is supposed to be same because this is the test, the real data. And this is the predicted data that is predicted by our model. And let's compare using manual style after data imaging it. So let's look at this versicolor, vertical. Is there anywhere difference? It's all the same. It's all the same. So your model is super good, 100%. It can predict it correctly. Again, it's 100% is not something that can be believed, but for the example, yes, fine. Let me see whether it's really all is correct. Yeah, let's go. Okay, so let's try to calculate this. What it's actually going to do is going to get the left hand side, and then it's going to divide by all the values that you're going to find. So what you're going to do is fix accuracy. So Zamri minus y. I don't know. I don't know whether you guys can see something, but for me, it's going to be under accuracy. Anything is different. Because when I was trying yesterday, I have one it predict wrongly, but today they didn't find that. It's all correct. But I'm not going to be very happy like wow, no, it's not believable, but it's possible because of our current environment or our current configuration. But it's going to be not going to be happening like this in the work and but it's okay. You kind of have the picture, all right? So. But I'm not sure about all of you. Maybe you might have different. Maybe you might have 0.9, 0.95. So you can share the chat if you have any other values that you're able to generate. Okay, and another important thing is that conversion matrix. Okay, Okay, so configuration matrix is another evaluation that you're always going to see. If you read a lot of research papers, when I need to review, that's the first thing I'm going to see. Okay, if anybody give 100%, surely that paper is going to have a lot of problems. So we're going to look at the configuration matrix, and that's how we see. We look at the configuration matrix first. Is everything fine? Then only we go to the methodology. Whether this configuration matrix is achievable by the methodology that we propose. So let me get the configuration matrix. Yes. Predict. Then we run. And this is the matrix. So matrix is simple because now you have 100% and it looks fine like this. Okay, it looks fine like this. But if it was fine, I have one error. So I'm here misclassified. I don't know, maybe you might have like that. I'm not very sure. Okay, maybe you might have something like that. Let me see. You see? Got error. Okay. So the iteration, because I believe it doesn't converge enough, then the thinking is not correct. Okay, now I set my iteration, I increase my iteration because by default, your regression gonna iterate 100 times if you didn't put any setting there. So I increase another 50 more times, then I notice it could actually skip. Then if you notice here, you're going to see that this fellow here, this is a misclassification. Means the original data is Vajinika, your model predict Vajinika. We call this as misclassification, that's a 2. And I have another one. Okay. So now your accuracy is not 100% by 0.8. It's still good. It's still super good. Okay. So yep, we already done our evaluation. Based on this result, we are happy with our model, and we think it's fine. Kalau you dapat 60%, 50%, then yeah. Usually research paper, I notice mostly will be 80% above, 90%. Unless you justify the by methodology, but this accuracy like 50%, 60%, it's questionable. 100% is kind of questionable. So it means that your evaluation done. So you're happy with your model, it's performing very well. And finally you can use your model. So this is where the deployment part comes. So today I didn't share. Let's say, for example, you're doing a project. This part usually will be an application or website. So we can do this also. So means you already have a model. You can just use this model. For example, FIB student projects where they're developing a mobile app, they're developing a website, and they can do prediction here. So this part they're going to do, and when they do, and they can just use this model that they train just now. Okay, there is a different environment itself, a different technology, different tools, and all. So let me just quickly, okay, the time is good. So I created a new data now. Okay, you can create any data you want now. So here I simply created, so I assume this is the data that is unseen, unknown. There is something new that your machine gonna predict, your model gonna predict. Okay? So I created a simple okay, so this is let's see particular data. Okay, so this data is going to look very simple. I just simply created myself. I assuming this is, I'm showing you this now we're going to use. So let's say you're developing a system that you ask the user to key in this values, and then your system able to predict what is the output. You're already having your first AI system. Okay, you can create a website or you can create apps where you ask user this for input, and then based on this learning, based on this model, you're going to predict what is the output. So there is basically your AI system, I think smart system now the thing, and then let's go to you can see right the code is simply like this. I just create a new point with these values. You can play around with this code. Later you exchange different values, and then you run and see what it is. So now what we're going to do, we can try to predict this and see what it gives you. With this kind of combination, let's try to predict what it gives you. So we have model, predict. So the data I have is UiTM, and it gives you Sentosa. Okay, so it's an unseen data. It's not this particular thing we assume is not inside the data set that we have. And you give your machine, and can you see it? Just now we human, we know, we learn, we see a pattern, and the machine doesn't know. Now we give it an algorithm, it learns. Now, if you give the parameters, it can predict what is the output, that is Sentosa. And this prediction, I can easily say is 93% accurate. The very high chances that this prediction is correct. That's how you justify your model. It's not, that's why I say 100% prediction is not going to, it's not that logical actually. And you are able to predict your first, you can just change this, let's say I change this into 4.0. It's a simple difference. Around that is going to be the same, but use it at the now you can also see color. It's trying to put this inside a two-dimensional plane where exactly this U point will be. So I'm almost reaching to the end. So it's good that I'm able to keep the time one time. So finally, the question that you all have to ask is, what is next? So after you're able to do all these things, the question that we're going to ask is, what is next? So can we have a better classifier performance? Okay, that's already the bagus data. Okay, but if you face other different data set, the question that you need to ask is, can we have a better classifier performance? So how to do that is a lot of data mining techniques, methods, data science methods is called pre-processing stages. So normalizing, scaling, feature selection, cross-validation. So you can try all these things. So this data mining process is all about trial and error. You need to, based on your knowledge, you need to keep on changing or adjusting until you get the best performance. Our model already 93%. So they're happy now. So we don't do anything. So this is fine. Let's say a model that is around 70%, I really think I can do better, then you try to consider all these things. Feature selection is kind of data reductions. So some of the features is not relevant to the model building. Okay, now another ultimate question is going to have which algorithm is better. Because now I can use logistic iteration to do this. So you can do the same using K nearest neighbor. On the classification organization tree, neural bias theorem, naive bias theorem. So there's so many algorithms still finite now. And even by now, but still there's a quite n numbers of that you can actually use. So neural network, all these algorithms. And you can actually compare which one is performing better. Who knows, you try K nearest neighbor. So terus dapat 100% exam. Then you can claim that KNN is better for our model than logistic regression. Usually in the research, you're going to see this kind of research is done about the data set. They'll apply a few algorithms, and then you'll discuss which algorithm is performing better for this particular parameter, this particular configuration, or this particular setup. So basically, that is going to be your next step, improving, keep on improving this until you get algorithm. Alright, so I'm to the last slide. So these are the learning materials, if you're interested. Okay, these are the learning materials for going to be useful for you. So the textbook is very famous one, Introduction to Data. If you click that link, the materials all are freely available. It's not the illegal one, it's the legal one. You can get all even the slides and all the things you can get. And the practical books you have to purchase one. Okay. There's a lot of books I just listed too that is kind of useful for us. Python for data analysis and machine learning with Python cookbook. So this cookbook is sufficient for you to really understand A to Z about Python and how to use it. But the thing is, I want you to notice if you try to Google this, you're going to have a lot of things, so it's going to be confusing. So today, I make things very simple. I just use pandas for pre-processing, cleaning, and visualization, and then I use HITeL as my machine learning model. So if you Google sometimes nowadays, you can even use TensorFlow. The TensorFlow is another popular machine learning, especially deep learning. So if you go to the different, and then the library is going to change, the code going to change, the syntax going to change. So it's very subjective, depends on the problem that you can solve. So I think I'm going to end my sharing session today. So I'll end with thank you very much for giving me the opportunity again for around, I think, almost 1.5 hours and patiently listening to this talk. Thank you very much. I pass back to our moderator.
Okay, thank you, Dr. Pradeep, for your thoughtful talks today. So, just to inform all the participants, the link attendance is will be shared in the chat. Okay, you may fill in the form. Okay, for your okay, all right.
Do I need to fill also?
Sorry?
Do I need to fill the link kehadiran juga?
Your yes, because we need your staff ID for recorded. So jam latihan, Pradeep. Okay, so
is it a question and answer session?
So far, there's no question right now. Maybe we can invite you for the intermediate workshop for this data mining Python with Python. That's about it.
Already booking.
Okay, we will invite you later on because ada request from other lecturers.
Okay.
They're not detailed. I think they want to more. They're not more towards the data mining good. Okay. All right. Okay. So I think can we have a photo session?
Okay. So I stopped the screen sharing.
Yes. Sure.
I think there's one question from Mohammed Nasir. How to check?
Oh, Nasir. Okay. Sorry.
Conversion. No, it's a conversion metric for training set. You can get, but the thing is, usually we use conversion metric after it's time to predict. So after it uses the training set and then you compare with the test set, then only we can actually, because we are trying to compare the prediction with the actual, then only we can get the conversion metric. So I hope I'm able to answer the Nasir's.
Please, will be okay. All right.
Ya, the link kehadiran nanti.
Tak dapat diklik. Tak dapat klik. You just copy the URL. Tak dapat. I have to check first. Okay, good. Okay, the link is okay. You can share URL. Thank you. Thanks, Ham. Okay, this one link I did also can. Alright. Okay, thank you, Dr. Pradeep. Can we have our photo sessions? So all the participants, can you open your camera for our photo session? Dia buka kamera ni.